Hi, statistics students. The purpose of this lesson today is to talk about the interpretation of slope, vertical intercept, and r squared for a least squares regression line. Okay, so prior to this video, you should already know how to find each aspect of the least squares regression line equation, and you should already know about it. For your own benefit, I just wanted to give a little bit of background on it, just in case you didn't know. Okay, your equation is your predicted y equal to your a plus your b times your x. And I'm going to break down each variable for you just in case, again, you didn't know. Your a is your vertical intercept, which is equal to your predicted, to your mean of your y minus your slope times the mean of your x. If you were given a table or any type of set of values or set numbers, you could find that out yourself. It's pretty self-explanatory. There you go, I underlined it for you, and those are your means. Okay, so we move on to your slope, which is your b in your least squares regression line equation. Is equal to your correlation coefficient, there you go, times your standard deviation of your y divided by the standard deviation of your x. Again, I just want to give a basic background of the least squares regression line equation. So it is time to move on to a practice problem. So here we go. This is a basic problem. It says that the fat and corresponding protein content of 24 sandwiches purchased from different fast food restaurants was analyzed according to bivariate techniques. It was determined that it was appropriate to assume that there is a linear relationship between two variables so that a line of best fit was created according to the method of least squares. The model is as follows. Okay, so I just wanted to highlight that it says line of best fit, which kind of goes with the least squares regression line and the method of least squares. So, okay, let's move on. So the equation is your predicted fat equal to 6.8 plus 0.97 times your protein, where your fat and your protein are both measured in grams. Yay, you have your variables, your explanatory and response variables are both measured in grams. Again, it is important to note the units of each variable because you will need those in your interpretations. So make sure you have that. Okay, so we go on to our correlation coefficient, which they provide for us, which is 0.83. And again, you can find that later. And here are the questions. I'm going to add in the vertical intercept, just slip that in there because again, this is the purpose of the lesson. At the bottom, I have provided you with r squared. Again, it's super easy to find because you just square the correlation coefficient. Super simple, right? Okay, so let's get started with the explanations or the interpretation of slope. Okay, so we have our slope of 0.97, or interpret the problem. It says that it should be that the slope of 0.97 means that on average, an increase of 1 gram of protein will correspond with the model prediction of an increase of 0.97 grams of fat. Okay, now I'm typing this out as I'm saying it, but you should also note that I'm using terms like on average because the least squares regression line is a prediction, it is a estimation. Also, I'm using terms like the model predicts or model prediction. Also, you have to include that. Also, note, in which I will kind of highlight a little bit as soon as I finish this kind of spiel of typing, that the slope is positive. So you will have an increase of a certain variable, of each variable. Now, if it were to be negative, then you would have, as it increased in protein, it would decrease in fat. That's how it typically works. Well, it always works. It's kind of unified. So there you go. I kind of highlighted those terms and the fact that the slope is positive. Yay! So let's move on. Oh, also that you need to include the units. Again, that's not interpreting it unless you have your units. Otherwise, it'd just be a random number that has no meaning. So let's move on to our vertical intercept. We have a vertical intercept of 6.8. The vertical intercept of 6.8 means that on average, again, that is really important that you have that. It means that if the sandwiches had 0 amount of protein, you would have 6.8 grams of fat in the sandwich regardless. Okay, which is pretty simple, but you would word it as the vertical intercept of 6.8 means that on average the model predicts that fat in the sandwiches, typing kind of slow, to be about 6.8 grams, having 0 amount of protein. So again, as I'm typing very slow, I can kind of ramble on about the explanation. Just make sure that you have your key points, your on average, and the fact that the model predicts, because again, the least squares regression line is just a prediction and an estimation. Also, without these key points, your interpretation will be incorrect. Again, you are explaining your vertical intercept. And with that explanation, you want to have everything. Otherwise, you will not receive points. I want to just kind of circle on average and model predicts just to give you another reminder. Also, referring back to the equation, just kind of Xing out, you know, that slope, because the protein is 0, you'll have left your 6.8. So let's officially move on to the R squared explanation. You have your R squared value of 0.6889. So this is how it would be explained. You would say that your R squared value of 0.6889 means that about 69% of the variability in fat can be explained by the linear model that exists between fat and protein. So basically, R squared is the percentage of the variation in the response variable values. So in this case, it's our Y value, or our predicted fat. And again, R squared is a percentage of the variation of the response values that can be accounted for by the linear relationship between your X and your Y, or in this case, your fat and your protein. So now that I am finally finished typing up the explanation of R squared, there you are, there it is completely. Don't forget that R squared is a percentage. Do not forget terms like variability, because that is exactly what it is. In this case, for the explanation of R squared, you do not need the units of the explanatory and response variable. But you do need to show that it can be explained by a linear model. Otherwise, it defeats the purpose of this whole entire explanation. So we have finally reached the end. This is it. The interpretation of slope, vertical intercept, and R squared. I hope this helps.